we left off with this one equivalent capacitor, which we had figured out all the details about. So now we want to work backwards, breaking them apart. So our first step back will be into the lower and upper. So this was C4, and this upper one was the combination of C1, C2, and C3. Now capacitors in series have the same charge, so each one of these will still have 67.2 microcoulombs. C4 is one of the original ones, so it's got 4 microfarads. This combination up here we figured out before had 6 microfarads. So the last thing that we do is determine voltage from our definition of capacitance. So we need to divide the charge by the capacitance for each one. And if we do that, we end up with 16.8 volts for this lower one and 11.2 volts for the upper one. And notice 16.8 plus 11.2 adds up to the total 28 volts we started with, as it should. So C4 is complete. That one's not going to change for the rest of what we do. So if we back up one further step, that's splitting this upper capacitor, following what we did before, into a combination of C1 and C2 and C3. C4 down here isn't going to change. So when we split this one apart, this one was 4 microfarads, and this one up here was an equivalent with 2 microfarads. We're splitting them in parallel, and in parallel, capacitors have the same voltage. So each of these are going to have the 11.2 volts. And then we calculate the charge left on each one from multiplying these together. And we have 22.4 microcoulombs on the upper one and 44.8 microcoulombs on the lower one. And again, as a check, 22.4 plus 44.8 is 67.2, as it should. So this lower one here, C3, that's now also complete. We know everything we need to know about that one. So the last thing to do is to break the uppermost one back into C1 and C2. So each one will have 4 microfarads because we're back to our original capacitors. We're splitting them in series, so each one will have 22.4 microcoulombs. And since they're all identical, they'll each also have the same voltage, which would be 5.6 volts each. And 5.6 plus 5.6 is 11.2. So that takes care of all of those. That answers parts A and B. We know the charge on each capacitor and the potential difference across each one. The last thing is the potential difference between points A and D over here. So if we look at how we would get from one point to the other, so here's point A, and here's point D. Now we've got 5.6 volts, 5.6 volts, and 11.2 volts. So no matter which path we take, if we go through this upper route to get there, we're going to move through a total of 11.2 volts. If we move through this lower route to get there, it's also 11.2 volts. And we're going to get back around to B. So if A is at 28 volts and B is at 0, 28 minus 11.2 is 16.8, which was the voltage on the lower one. So you'd cross that and get back to 0.